Hello, this is Mr. Collier, and today we're doing the toxic waste dump problem. It's called that because in this situation, unlike a fire department or something, if you have something like a toxic waste dump, you want that to be as far away from houses or communities as possible. So in this diagram here, we got 3 towns, 3 sites, and if we check it out, the spot where we can put the toxic waste dump, so that's the furthest away from all 3 places, is actually at the vertex of this Voronoi diagram. Okay? Alright? Because points in here are closer to C than they are to A, so if you're right on the boundary, these points are an equal distance away from A and C, and then once you go to the vertex, you have a point which is an equal distance away from A, C, or B. So it is the best spot to put the toxic waste dump, and it lies on the vertex. Okay. So let's move on to an example. Okay, here's a Voronoi diagram with 4 sites, and there's 2 vertices in the diagram. So there's 2 possibilities for our toxic waste dump. It could be here at point F. Now point F is the vertex between the A, D, and the B, so you can draw a circle through A, D, and B. It's not a very good circle. E, so we can go through E, and that is D, C, and B, so you can draw a circle through here. And this is not a very good, it's not a very accurate circle, but it's obviously larger, which is the point, okay? So it would be better to put it at site E, because, so the 2 possibilities are F and E, but the best choice would be E, because the distance is further away from sites C, D, and B. Okay, so we have the diagrams drawn on the next page as well, and you can more accurately, and you can see that this circle is a lot bigger. Okay, given the coordinates of E are 5.5, 4.5, how far will the new burger bar, so this is about a burger bar rather than a toxic waste dump, how far is it from the nearest existing one? So let's find that point. It's 5.5, 4.5, and to the nearest existing one, well, there's existing ones at D, E, and D, B, and C, so we just use one of those to find the distance, and it should be the same distance because the radius of the circle is the same in all 3 locations. So the distance is, we use the distance formula. Okay, and the C value here is 6, 8. Okay, so we'll have square root of 6 minus 5.5 squared plus 8 minus 4.5 squared. And we've typed that into our calculator. We get about 3.54. Okay, 3.54. Okay, we got another example coming up. A town has 4 coffee shops, which are shown on the Voronoi diagram. A business wishes to open a new shop in town, but would like to be as far away as possible from the existing shops. Where should they put it? So here we have a 4-site Voronoi diagram, and we can put it at P or put it at Q. So find the exact coordinates. We're not going to find exact, we're going to find the coordinates of points P and Q on the Voronoi diagram. So P is, now this appears to be the midpoint of B and D. Yeah, actually the midpoint of C and D is right here at 3.5, so this must be up at 3.5. So the coordinates of point P are 5, 3.5. Now point Q is a little bit trickier. Okay, so we know the equation of line QP. Well, we have a point, and we need to find the slope. We can find the slope of BD first. Slope of BD, we use the slope formula, is 5 minus 2 over 8 minus 2, because this is 8, 5, and this is 2, 2. So that gives us a slope of this line BD. That is 3 over negative 6, which is negative half. Or sorry, positive 6, which is positive half. So the perpendicular slope to that is going to be negative 2. So this line has a slope of negative 2. So we can write in point slope form. The coordinates of point P are this, so it's y minus 3.5 equals negative 2 times x minus 5. And if we rearrange this for y, we get y equals negative 2x plus 13.5. Okay, so that's the equation of this line. If we want to find the coordinates of point Q, we'll need to find maybe the equation of this line. Okay, so let's go ahead and do that. Slope of AB is, well, we can see it here by counting if we want to. This is 1, 2, 3, 4. It's negative 4 over 1. So the perpendicular slope is 1/4. Okay, and yeah, the midpoint here is, that's going to be a y value of 4. So y minus 4. And the x value is 1.5, so it's going to be 1/4 times x minus 1.5. Okay, if you rearrange that for y, you get y equals 1/4 x plus 3.625. Okay, Q is the point of intersection of these two, so we can simply graph that on the graphing calculator and find the point of intersection. And if you do that, the point of intersection is 4.39, comma 4.72. So that's the coordinates of point Q. Okay, so once you get that now, where would you recommend the new shop to be sited so it's furthest away from any possible shop? Well, you can find the distance PD, for instance. Okay. So P is, yeah, it's equidistant from all these here. So let's find PD. PD is using distance formula again. That, if you type into your calculator, you get 3.35. Okay. Now Q is equidistant from A, B, and D, so we can actually do QD to find that distance. And we use the distance formula on that. And we get about 3.62. Okay, so we want it to be as far away as possible. So this distance is 3.62, this distance is 3.35. So it's better to have it placed at point Q. So point Q is better.